Look up at the night sky. Go ahead. Pick a star. Any star. That light you're seeing, it's old. Not a little old. Ancient. Some of those stars died millions of years ago. You're looking at ghosts. And that's just the beginning of how wrong your perception of the universe actually is. Everything you think you understand about space, the distances, the scale, the sheer size of it all, is a comforting lie your brain tells you so you don't break down in existential terror. Because here's the truth. The observable universe is 93 billion light years across, and that's just the part we can see, the part where light has had enough time to reach us. Beyond that, we don't know. The universe might be infinite. It might be so large that the difference between infinite and incomprehensibly massive doesn't matter. And the scariest part? It's getting bigger, faster. The universe is expanding so quickly that galaxies are disappearing from view. Not because they're dying, because they're moving away from us faster than light itself can travel. You're not ready for this, but let's go there anyway.
Let's start with something we think is fast: the speed of light. 299,792 kilometers per second. In 1 second, light can circle Earth 7.5 times. That sounds fast. It is fast. It's the fastest thing that exists. Nothing in the universe can move faster. But against the true scale of space, light speed is agonizingly, brutally slow. Look at the moon. When you see it tonight, you're seeing it as it was 1.3 seconds ago. The light took that long to reach your eyes. The sun? 8 minutes away. If the sun exploded right now, we wouldn't know for 8 minutes. We'd keep living, completely unaware, watching sunlight that's already a lie. Proxima Centauri, the nearest star, is 4.24 light years away. Light takes over 4 years to cross that distance, and that's our closest neighbor. Everything else is farther, much farther. The fastest spacecraft we've ever built would take 6,500 years to reach Proxima Centauri. Not generations, thousands of generations. Light speed is the cosmic speed limit, and it's not fast enough. Our galaxy, the Milky Way, is 100,000 light years across. Think about that. A beam of light traveling at the fastest speed possible would take 100,000 years to cross from one edge to the other. Human civilization, agriculture, writing, cities, everything has existed for about 10,000 years. The galaxy is 10 times that in light years. We sit about 27,000 light years from the galactic center, not at the edge, not in the middle, somewhere unremarkable. The Milky Way contains between 200 and 400 billion stars. Most of them probably have planets. The galaxy is so large that our sun takes 225 million years to complete a single orbit around the center. The last time we were in this exact position, dinosaurs didn't exist yet. And this is just one galaxy, one single galaxy in a universe of trillions.
The nearest large galaxy to us is Andromeda. You can see it with the naked eye on a clear night, a faint smudge of light. It's 2.5 million light years away. That means the light you're seeing left Andromeda before our species existed, before Homo sapiens evolved, when our ancestors were still upright apes learning to use tools. And Andromeda is our neighbor, the closest one. Between us and Andromeda is almost nothing. Intergalactic space contains less than 1 atom per cubic meter. The best vacuum chambers we've built on Earth can't even come close to that level of emptiness. Most of the universe isn't stars, isn't galaxies, it's void. Cold, dark, empty void, stretching for millions of light years in every direction. And here's the disturbing part. Andromeda is moving toward us. In about 4 billion years, it will collide with the Milky Way. Not a violent explosion. The stars are so far apart that they'll mostly pass through each other. But the galaxies will merge. The sky will change. New stars will form from the collision. And if any humans are still around, they'll witness something no one alive today can even imagine.
Zoom out far enough, and something strange happens. Galaxies aren't randomly scattered. They form patterns, structures, filaments stretching hundreds of millions of light years across the universe, connecting at nodes where galaxy clusters sit. Astronomers call it the cosmic web. It looks biological, like neural networks, like fungal mycelium. Long strands of matter with enormous voids in between. Some of those voids are 300 to 400 million light years across. If our galaxy were inside one, the night sky would be nearly empty, just darkness, a few faint smudges at most. The Milky Way, with its hundreds of billions of stars, is just a single tiny node in one small filament of this cosmic structure. We're not even a speck. We're a speck on a speck. Here's where things get truly incomprehensible. The observable universe, the part we can actually see, is about 93 billion light years across. Wait, how is that possible? The universe is only 13.8 billion years old. Light hasn't had time to travel 93 billion light years. Here's the answer. Space itself has been expanding the entire time. Light from distant galaxies has been traveling toward us for billions of years, but while it was traveling, the space between us and the source kept stretching. The result is a visible bubble much larger than you'd expect. But here's the terrifying part. There's a horizon, a limit. And beyond that horizon, we will never see anything, ever. Not because the light hasn't reached us yet, because it never will. Space is expanding so fast that some galaxies are already receding faster than light can travel. The distance between us is growing faster than light can cross it. That information is gone. Not delayed, gone forever. The observable universe contains an estimated 2 trillion galaxies. Each one contains billions or hundreds of billions of stars. Most of those stars have planets. The total number of planets in the observable universe is higher than the number of grains of sand on every beach and desert on Earth, by a factor of thousands. And that's just what we can see. Beyond our horizon, the universe keeps going. We don't know how far. It might be infinite. It might just be so incomprehensibly large that the difference doesn't matter. One estimate suggests that the observable universe is to the full universe what an atom is to a continent. We're not just small, we're negligibly small, invisibly small. Here's something most people don't think about. When you look at the night sky, you're not seeing the present, you're seeing the past. The moon, 1.3 seconds ago. The sun, 8 minutes ago. Andromeda, 2.5 million years ago. The most distant galaxies we've detected are seen as they were when the universe was only a few 100 million years old. They might not even exist anymore. They could have merged, transformed, or been destroyed billions of years ago. We're just now seeing the light. The sky isn't a window, it's a time machine. Every star, every galaxy is a photograph from a different era. And the farthest thing we can see, the cosmic microwave background, is light from 380,000 years after the Big Bang, the oldest light in the universe. We're surrounded by ghosts, echoes of a universe that no longer exists in that form. So let's review.
The observable universe is 93 billion light-years across. It contains 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. Most of those stars have planets. And that's just what we can see. Beyond our horizon, the universe might be infinite, or so large that infinity doesn't matter. Space is expanding so fast that galaxies are disappearing. The universe we can observe is shrinking, and everything we see in the night sky is already gone. We're just seeing the light it left behind. You are standing on a small rock orbiting an average star in an unremarkable galaxy, in one tiny filament of a cosmic web that stretches across distances your mind cannot process. And the scariest part? We might be completely alone in all of it. Or we might not be, and we'll never know, because the universe is so large, so empty, and expanding so fast that even if there are others out there, we'll never reach them. The distances are too vast. The speed of light is too slow. The universe doesn't care. You weren't ready for this. No one is. But now you know. The universe is bigger than you can imagine, and it's getting bigger every second. And we're stuck here, on this tiny rock, watching it all drift away.